In this video, we were talking about applications to physics and engineering with moments and center of mass. So as you can see here, you can find the moment. So let's look at an example of how we can use this. So let's take a look at this question. So it says, point masses mi are located on the x-axis as shown. Find the moment m of the system about the origin and center of mass. So what we got to do here is finding moment m. So as we saw from the equation, you can just get it for reference. So basically, all we gotta do is gather up all the masses and all the x point locations, and we gotta add them up. We gotta multiply them and add them up. Let's start up with the first one. So here we have first mass equal to 12. So we can just put like this. So we got the first mass, this is M1, and we got the x, first x. So we can just name this x1. Then we gotta get another mass. So the other mass is M2 equals 15. So this is just M2, and then the X2 is going to be 2, because as you see here, is right there. And the last mass is 20, so that is M3, and the last X would be 8, that is X3. So since we have all our masses and X coordinates, we have to add them up. So 12 times negative 3 is going to be negative 36. 15 times 2 is 30. And 20 times 8 is going to be 160. And when you add them all up, you're going to get 154. So this answer is the numerator. So we didn't get the denominator yet, so we had to find it. So the denominator, all the masses in the bottom, so this would be M1 plus M2 plus M3. So we know that M1 is going to be 12, M2 is 15, M3 is 20, and when you add them all up, you'll get 47. So now we gotta find our x, or moment. So we have our numerator and we have our denominator, and this is pretty much our answer right here. This is the moment of the problem. All right, let's look at this problem. So it says the masses mi are located at the points pi. Find the moments mx and my and the center of mass of the system. So we got like a bunch of stuff over here. So we got four masses and we got four points which have x and y coordinates. So the first thing we want to do is find up the masses because that's easy, right? So all the masses. So we got m1 plus m2 plus m3 and 4. That would be equal to, so 4 plus 3 plus 6 and plus 3 again. So this would be 10 plus 3 equals, this would be equal to 16. So our combined masses will be equal to 16. Our combined masses is 16, so yeah. Now we go to the hard part. So here we got to find out all of the moments from the mx and my. And what I mean by that is basically when you see all the points, they have x and y coordinates. X, y, as I'm showing here. This is x, this is x, and this is x2, y2, and etc., etc. And what we're gonna do is basically where it says M1, the M2 and the P2 they coordinate each other. So and M3, etc. So basically for MX we have to get multiply the mass times the x. So this is the equation for the first one. So you will multiply all the m's and the y's to get the mx or the moment of mx. So for P1 the y would be 1 and the mass would be 4. So this would be equal to 4. And you basically do this the same thing for everything. So basically you do this for the everything else. So 3 times -1 would be -3, and 6 times -2 would be, or 6 times 2 would be 12, and 3 times -15 is -15. 3 times -5 would be -15. When you add all of these up, including the 4, so 4 plus -3, that's -1, plus 12 is 11, and plus -15 would be equal to -2, and now we gotta find the y. So we got this, now we gotta find my, so this would be 4. Basically over here we would have 4 times 6, that would be 24. 3 times 3 equals 9. 6 times -2 is -12. And 3 times -2 is -6. So let me write this all down. So 4 times 6 equals 24. 3 times 3 equals 9. 6 times -2 is -12. And 3 times -2 is -6. And all of that will be equal to 15. We got all that here. And our third step and final step would be just getting our coordinates. So this would be, so as you can see here, y is 15. Now, and our masses was 16. The hidden masses was 16, so this would be 15 over 16. And our mx was -2. Masses was 16, but we can distribute that. We can we can simplify that further. So that would be -1 over 8, and this is our final answer for the question. Here's a centroid for the equation. This is all you need to know for the centroid. So this is pretty much the same, the basic integral, you got the fx, and 1 over a, that is the area, and for the y, it will be 1 over a, the integral, same thing. You got a 1/2, and you got a function that is squared. It's pretty much the same. Um, I'll be doing that for this video, but I might do it for another video, so. And we got centroid of two curves. We got centroid of two curves. This is pretty much all I need to know for the centroid. If you have a problem like this, and I'm gonna show you how to use it in this example. So we're trying to find the centroid of the region bounded by the curves, and as you can see from the screenshot, you can use this equation for this problem. So first of all, we're going to find the area. We can find our area, and immediately we can tell we have to find our bounds for the curves. So we can just set these up equal to each other. So y equals x2, and y2 equals x. We need to get it in terms of y, so this would be square root. You can set the y's equal to each other. So this would be x squared equals x, and we can plug in just two random numbers. Let's plug in 0 and 1, because in this situation it will work. You plug in 0 for 1 for the x's, they will be equal to each other. So we can use that for our example. So this would be 0 to 1, and we can plug in our fx and gx. So our fx would be x 1/2 minus x2, because if you're graphing this, the y squared would be on top. So let me just put this right here, and this would be on bottom. So this would be y equals square root of x. This would be y equals x squared. So yeah, basically it's top minus bottom, like the areas. Pretty simple. Then we got to integrate it. So this would be 2 over 3 x 3 over 2 minus 1 over 3 x to the power of 3 from 0 to 1. And when we plug in these functions, we will get just 1 over 3. In this situation, we would just plug in what we got. So we could just plug in our x. So x would be 1 over a. So that would be, so our a was 1 over 3. So we could just plug in 3 for that from 0 to 1. And we could plug in our normal function or our integrated function. So, and we can integrate this. So our integration would be 2 over 5 x 5 over 2 minus 1 over 4 x to the power of 4 from 0 to 1. And that will lead us to 9 over 20. So if you plug this in, this will be equal to 9 over 20. And we got to find our y value. So pretty much the same. So our a would be 3, be 1 over 8 times 1 over 2. That would be 3 over 2. So just like that. Now we gotta like do the hard stuff. So we got x to the power of 1/2 minus x squared. This would be 3 over 2 from 0 to 1. X minus x4. We can integrate this. You can plug in 0 to 1 for all of these. So plug it in. This will be 0. So it'll be 1 over 2 minus 1 over 5. And we have to find the same denominator. So this would be 5 over 10 minus 2 over 10. So this would be 3 over 10. And we can multiply, we still have 3 over 2, so let's multiply 3 over 2 times 3 over 10. This would be 9 over 20, and that would be our y. And now our final step is going to be just plugging these our answers in. So for x we got 9 over 20, and our y was 9 over 20 again. So this is our final answer. For this, you have to practice. Just use the formula sheet for reference, and you'll be set.